In order to assign the configuration of a stereocenter, we need to begin by assigning priorities to each of the four groups around the stereocenter. For example, this carbon right here is a stereocenter because it has four different groups on it. It has a methyl group, an OH, a hydrogen, and an ethyl group. Four different groups, that's what makes it a stereocenter. And what we need to do is we need to go through and prioritize the groups according to atomic weight. So if we make a list of what's connected to this carbon atom here, we have an oxygen, a hydrogen, a carbon, and a carbon. Oxygen has the highest atomic weight, that's going to be number 1. Hydrogen has the lowest atomic weight, that's going to be number 4. Now, carbon and carbon have the same atomic weight. So we need to look at the 3 atoms that are connected to this carbon and the 3 atoms connected to this carbon. So we have H, H, and H. Let's make a list. H, H, H. And here we have H, H, and a C. This carbon, other than the stereocenter, is connected to a carbon and 2 hydrogen atoms. Carbon and 2 hydrogen atoms. And carbon beats hydrogen, therefore this wins, and this gets the 2, and this gets the 3. That's the first step in being able to assign the configuration R or S to a stereocenter, is being able to prioritize the 4 groups in terms of 1, 2, 3, and 4. Before we say how to use that to assign the configuration of R or S, let's just say that you actually have to go through this process that we just went through here. It's not enough to simply look at the ethyl group and the methyl group and say, oh, the ethyl group is bigger, and therefore that's going to get the priority. Because look at the following example. Here we have a stereocenter, and if we were to try to prioritize this stereocenter, we would say that the oxygen gets the 1, there's a hydrogen on here, and that's the number 4. And then we have carbon and carbon. Which of the 2 gets the priority? Which one is 2 and which one is 3? And intuitively we might say this side is bigger, this gets the 2 and this gets the 3. But not so. Why not? Here we have a carbon atom, here we have a carbon atom. So let's compare these two to each other. This carbon atom, other than the stereocenter, is connected to 3 atoms. Carbon, carbon, and hydrogen. Carbon, carbon, hydrogen. This carbon atom, other than the stereocenter, is connected to 3 atoms. Carbon, hydrogen, hydrogen. Here we have a tie. Here's our first point of difference. C beats H. Therefore, this side wins. This side wins. This gets the number 2 priority, and this gets the number 3 priority. Now, once we've assigned priorities, we then need to convert that into R or S. So let's say we have a stereocenter, and we have already assigned priorities. And let's say it looks like this. 1, 2, 3, 4. It no longer matters what the groups are anymore. Now that we've got 1, 2, 3, 4, we can assign the configuration. The easiest ones to assign are when we have the 4 position on a dash. So for example, like this. When you have the 4 position on a dash, the problem is set up and easy for you to solve. What you do is you look at 1, 2, 3 and determine whether it's clockwise or counterclockwise. 1, 2, 3. This arrow is going counterclockwise. That's S. If we were to have something like this, where the 4 is on a dash, 1, 2, 3. Once again, the 4 is on a dash, so it's set up for me to solve the problem quickly. I just look at 1, 2, 3. 1, 2, 3 is clockwise, so that's R. Clockwise is R. Counterclockwise is S. And it's very simple to do when the 4 is on a dash. What do you do when the 4 is on a wedge or the 4 is on a line? So to deal with a situation like that, there's a simple solution. What you do, let's draw it out again. Let's say we have a 4 on a wedge, and let's say it looks like this. So the 4 is on a wedge, not on a dash. So what we need to do is we need to imagine it were on a dash. Where would this need to be in order to be on a dash? It would need to be right here. So let's imagine switching places between the 3 and the 4. Let's imagine keeping the 1 and the 2 in the same place, but switching the places of the 3 and the 4. So now the 4 is on a dash and the 3 is on a wedge. Now, in doing so, I have changed the configuration of the stereocenter. Anytime I change two groups, any two groups, it doesn't matter which two, if I switch two groups, I change the configuration of the stereocenter. But notice that I've made it easier to do now, easier to solve, because the 4 here is on a dash. So now 1, 2, 3 is counterclockwise. Counterclockwise is S. Now, if this is S, then it must be that this was R. So that's a trick you can always do. When the 4 is not already on a dash, put it on the dash, and whatever used to be on the dash, put it where the 4 was. You've now changed the configuration. Assign the configuration, and then just make sure to switch back. If you're going to use this trick, make sure to switch back. Don't write S as your answer, because if you write S as your answer, you are writing the wrong answer. When you do the switch, you are getting the wrong answer, but when you get that wrong answer, you can use it to figure out what the right answer is. So don't forget to do the switch back when you use this technique.